Alright, so this is going to be the review for the Chapter 1 test. Like every single test that I give, if you could do every problem on the review, you should be absolutely fine on the test. I never try to put something on the test that isn't just like something on the review. And, you know, you've got to be getting close to a deadline to turn in your homework. And, you know, homework is never worth points, but it gives you the opportunity to use that note card. So it's kind of huge. Again, you can take pictures of it and just send me the pictures. You could scan it to me and email it to me, or you can bring it to me in my office. All my assignments tend to be a little bit long, and so I might not check too much. I'll just get to the answers. But most every problem on this review is probably pretty easy to check. So if you have the time, you should check it. And for every review this semester, you should complete the review before watching the videos, so that you're not having to write down everything I say, and it's watching the video over the review is just reinforcing what you know and filling in the kind of the gaps of what you don't know. So I don't hope for anybody to be watching this review before they've done it. It's just not going to help you prepare for the test as well as if you do it before. So I don't need the template, but if you need the template, I'll write it down quickly here. If the signs have nothing but pluses, you get a couple pluses. If it's minus plus, you get a minus minus. And in the other two cases, you get plus minuses. So the two problems on this first page are different strategies. Even though they both have minuses, the top problem fits this mold, and in this mold my sign should be plus or minus. The instructions are just a factor. When I factor, I don't set the parentheses equal to 0 because there isn't an equal sign. And the two problems on this page that I have written, there's three terms, there's no common factor, and there's no need for bottoms up because there's not a number in front of the squared term. What I need to do is fish around for the right lasts, and my choices would be 1 and minus 18. I don't see a 7 there, so I'll move it away and not do minus 1 and positive 18. And then 2 and minus 9 and negative 2 and positive 9. I don't even need to move on to the 3s and 6 because I can see the 7 that's starting to happen here. The top one, 2 minus 9, would give me negative 7. That's not the pair I'm going to need because I need a positive 7. And a negative 2 plus 9 would give me a positive 7. So in my parentheses, I'm going to put a positive the plus next to the 9 and the minus next to the 2. Just because it's the first problem, let me check this. I check a factoring problem by foiling. Well, most factoring problems I check by foiling. Here the firsts would be x times x, which would be x squared. The outers are x times minus 2, which is a minus 2x. The inners are 9 times x, which is a plus 9x. And the lasts are 9 times negative 2, which is minus 18. And the outers and the inners, because they have different signs, you subtract the numbers, take the sign of the larger. That will give me a positive 7x. The x squared and the minus 18 stick around. And I know my answer is correct. You would lose points, probably a few points, probably like 3 points, if on any of the problems that don't have an equal sign, if you wrote answers by taking the contents of the parentheses and setting them equal to 0. So if your answer was x equal negative 9 and 2, it probably would be a minus 3. My best guess is there's going to be either 20 problems worth 5 points each or 25 problems worth 4 points each. If the problems are worth 5 points each, you'd probably lose 3. If you did this wrong thing, if the problems are worth 4 points each, you'd probably lose 2. And I only do this step, set the parentheses equal to 0, when the problems have an equal sign. None of the first problems have equal signs, so I'm not going to do that extra step. The extra step is wrong, and you lose points if you do it. The second problem on this page is this template. So it's a trinomial. It doesn't have a common factor, and I don't need bottoms up because there's not a number in front of the z squared. And then the lasts, I need to do double negative factors of 36. So -1 and -36, that doesn't look like 13. -2 and -18, -3 and -12, -4 and -9, -6 and -6. This is the pair because -4 minus 9, they have the same sign, so you add those numbers and keep them negative. So in my parentheses, next to one of the minuses I need a 4, next to one other one of the minuses I need a 9. That's a perfectly good answer. It would be equally correct if I wrote z minus 9 times z minus 4. It would be wrong if I wrote, and you'd lose points if you wrote z equal to 9 and 4. Again, that's either a -2 or a -3 depending on how many points the problem is worth. And again, you only write answers with equal signs if the original problem doesn't have, if it actually has an equal sign. And the problems in this page don't have equal signs, so it's wrong to do that. Each of the problems on the next page have a leading negative, and when the first piece is a negative, you have to factor out at least a negative, and if there's a common factor, you factor out the common factor along with the negative. Part C of number 1, there isn't a common factor, but the leading term is negative, so I'm going to factor out a -1. And when I factor out a -1, I write a parentheses, and inside the parentheses I write the opposite of every term. The opposite of -y squared is positive y squared. The opposite of positive 5y is -5y. The opposite of positive 14 is -14. That -1's going to stick around, but it's not going to be part of my 2 parentheses factoring. So now I ignore, and I ignore, and I try to factor y squared minus 5y minus 14. I'm going to do that by creating 2 parentheses. I don't need bottoms up because there's not a number in front of the y squared. The signs are plus and minus. And then I start hunting around with the 14. I could do 1 and minus 14. I don't see a 5 there, so I'll move on to the next. I could either do 2 and minus 7 or minus 2 and 7. The pair that I need is the 2 and the minus 7, because 2 minus 7 is -5, and -2 plus 7 is +5. So I can tell I need a +2 and a -7. And I'm going to bring that -1 and incorporate it into my answer, and I'm done. This is the answer to part C of number 1. If I really wanted to check, this is how I would check. To check, the first thing I would do is multiply -1 into the parentheses that it's next to by going -1 times y and -1 times 2. -1 times y, I'll write -1y. -1 times 2, I'll write -2. And then I'll FOIL. I'm done with the -1, and now I'm going to do firsts. -1y times y. That's -1y squared, or just -y squared for the firsts. The outers are -1y times -7, which is +7y. The inners are -2 times y, which is -2y. The lasts are -2 times -7, which is +14. The outers and the inners are going to give you a 5y. So I'm going to get a -y squared plus 5y plus 14. That better be what's written under the pen, otherwise my answer is wrong. And I look at that and that, they're the same, so I know my answer is right. In part D, there's a negative first, so I have to factor out a negative. All the numbers are divisible by 2, I have to factor out a 2, and all the terms have a y. The smallest power of y that they have is y to the first. I'm going to factor out a negative 2y at my first step. And I know what to put in the parentheses, but if you don't, you could do this. The first term was negative 2y cubed. I factored out a negative 2y. I'll divide by what I factored out. The negative 2's cancel. I started with 3 y's. I took 1 y out. I'm left with a y squared. For the second piece, it was a negative 10y squared. I factored out a negative 2y. The negative 10 over negative 2 is positive 5. There were 2 y's. I took 1 y away. I'm left with 1 y. And the last, there was a positive 48y. I factored out a negative 2y. 48 divided by negative 2 is negative 24, and I took its y away. So that's the first step. That's the common factor factoring. Made sure to factor out a negative because the first term is negative. Now I'm going to 2 parentheses factor, and when I 2 parentheses factor, I'm ignoring most of what I see except for the contents of the parentheses. And again, it's not bottoms up because there's not a number in front of the y squared. I'll write a couple of y's first. My signs are going to be plus and minus, and then I'll work on this 24. I could do 1 and minus 24. That's not close to a 5. I'll move on from it. 2 and minus 12. That's more of a 10 than it is a 5. I'll move on from it. 3 and minus 8, or minus 3 and 8, both give me a 5. The 3 and minus 8 give me a negative 5, and the negative 3 and positive 8 give me a plus 5. I need a plus 5, so I'm going to do a negative 3 and a positive 8. So the 8's going to go next to the plus, the 3's going to go next to the minus, and with the common factor adjoined to that, that's going to be my answer. You can check this similarly to how I checked part C. And again, my videos are, embarrassingly long as it is. I don't want to check everything. And then the not checking everything, there's a certain danger to that because that means I could be writing down a mistake, and it's not good for anybody, but I hope I did that okay. E and F, the signs are beautiful because there isn't a minus sign. I know the signs are double pluses. Neither E nor F has common factors, so I don't have to worry about common factors. I really don't have to worry about signs. There are a couple minuses, a couple pluses should I say. In E, because of the number in front of the x squared, this is when you're getting a bottoms up. So the first step in bottoms up is I'm going to multiply, and what I'm going to multiply by, I'm going to multiply by 6, and what I'm going to multiply by 6 is that 5 at the end. So that's the first step of bottoms up. And then I factor, and again, this is now easiest factoring. There's no minus sign, so I don't have to worry about my signs or double pluses. There's nothing in front of the x squared, so I split the x's up. And now I look at the 30. Positive factors of 30 are 1 and 30, 2 and 15. That actually gives me a 17 and not a 13. It's the 3 and 10 that I need because 2 plus 15 is not 13, it's 17. 3 plus 10 is my 13. So next to one of the plus signs I need a 3, next to the other plus sign I need a 2. And now I need to finish up. I started off multiplying by 6, I need to divide by 6, and then after I divide by the 6, any fraction that's reducible I need to reduce, and they're both reducible. The first fraction is going to reduce to x plus 1/2 when you reduce by 2. The second fraction, when you reduce by 2, you get x plus 5/3. And then to finish up bottoms up, I do the name step. Bottoms up is going to give me the answer of 2x plus 1 times 3x plus 5. And you could FOIL that to check, but I'm pretty sure that it's right. For part F, double parentheses, no common factor, no negative to factor out, and I'm going to start making 2 parentheses. I know I need a couple of x's, and since there aren't any minus signs, my signs can only be pluses. Then I'll start working on the lasts. The only choice for my lasts, they have to be double positive, as a positive 1 and a positive 3, and a positive 1 and a positive 3 don't add up to 2, they add up to 4. A negative 1 and a positive 3 would add up to 2, but that wouldn't work. So it would be wrong if you decided, heck, I can go x plus 3 times x minus 1, because if you foiled that, the first would be x squared, the outers would be minus 1x, the inners would be positive 3x, the last would be minus 3, and this would combine to be x squared plus 2x minus 3. That sign would be wrong. So I'm not allowed to use signs, the factors of 3 that have a negative in it. I can only use the double positive factors of 3. The double positive factors of 3 add to 4. I can't find some factors of 3 that add to 4. That makes this whole thing prime. So not every trinomial's got a factor. I have to kind of force them to factor. If I randomly make one up, they usually don't factor. All right, so both problems on this page have common factors, and the top ones, the sign's not an issue. The bottom one, the signs when you have a minus and minus, the signs when you have a minus and minus are a plus and minus. For part G of number 1, I'm going to factor out a 3. When I factor out a 3, I divide all the numbers by 3. I'm left with 3n squared plus 8n plus 5. And now I'm going to ignore that 3. I'm going to ignore the original problem, and I'm going to attack the inside of the parentheses. And because there's 3 terms and there's a number in front of the first term, I need to do bottoms up. So I'm going to bottoms up this. I'm going to start off and I'm going to multiply by 3, and I'll get n squared plus 8n plus 15. Then I'm going to factor this, and it's lovely that it's a double positive, so I know my firsts are going to be a couple of n's because there's not a number in front of the n squared. I'll split the n's between my 2 parentheses. When there aren't any minuses, the only signs you can get are pluses. And then for the 15, its only factors are 1 and 15 and 3 and 5. And the 3 and 5 are the ones that give me the 8. So I'm going to do plus 3 plus 5. I'm going to finish up my bottoms up by dividing by 3. So I'm going to divide that 3 by 3, that 5 by 3. Then I'm going to reduce and bottoms up in a one big step. The first reduction, 3 over 3 gives me 1. The second fraction doesn't reduce, so I bottoms up and get 3n plus 5. It would be wrong if I forgot this common factor, so when I go to write my answer, I better have that common factor in there. So this is my answer. And again, anytime I factor, I can check. I don't check a lot because it takes time, but let me show you how to check this. To check this, the first thing I'm going to do is multiply the 3 in the parentheses that it's next to by going 3 times n and 3 times 1. That will give me a 3n plus 3. And then I'll multiply by the second parentheses by foiling. The first would be 3n times 3n, which is 9n squared. The outers would be 3n times 5, which is plus 15n. The inners are 3 times 3n, which is plus 9n. The lasts are 3 times 5, which is a plus 15. I'm going to combine the inners and the outers, and I get 9n squared plus 24n plus 15. And I look at that, I look at the original problem. This thing that I wrote answer on has to be right then. If I miss the common factor on h, then I'll make way more work than I need to do, and bottoms up actually gives you the wrong answer if the problem that you're trying to bottoms up has a common factor in it. So I'm going to pull out the common factor. All the numbers are divisible by 4, I believe, and they all have an x. I'm going to factor out a 4x. It's easy for the first one. I divide 4 by 4 and get a 1. I had 3 x's. I took 1 away. I get 2 x's. I'm not changing any signs because I didn't factor out a negative, so I'm going to bring this negative down. The 16 I'll divide by 4 and get 4. There were 2 x's there. I took 1 away. I'm left with 1x. The third piece, to figure out what goes in the parentheses, I know that minus sign's going to stay, and then I need to go 84 over 4, and 84 divided by 4 is 21. So the number I'm going to get at the end of my parentheses after that minus sign is a 21. And it had an x, but I factored the x out. So that's good for the first piece of my work. Now I'm going to ignore the beginning problem, if I could, and ignore the common factor, and double parentheses this. And because the signs are minus and minus, I get a plus and a minus. And because there's no longer a number in front of the x, I get an x plus and an x minus. Then for the 21, I can do 1 and minus 21, minus 1 and positive 21, 3 and minus 7, or minus 3 and positive 7. These are the ones that are close. 3 and minus 7 gives me a negative 4. Minus 3 and plus 7 gives me a positive 4. So I need the positive 3 and minus 7. So next to the plus sign I'll put a 3. Next to the minus sign I'll put a 7. And I can't forget that common factor. It needs to be part of my answer. So I'll shove it in, and I'll call that an answer to part H. So 4x times x plus 3 times x minus 7. Square problems, then cube problems. Square problems only factor when there's a minus. So for these two problems, I can tell they're both square problems because the exponents are 2 and there's only 2 terms. That's generally a square problem. Square problems with a plus are prime. Square problems with a minus factor, and you get 2 essentially identical parentheses by square rooting the numbers and dividing the exponent of the letter by 2. So from the first part of each parentheses, the first are going to have a 5b, square rooting 25 to get 5, dividing the exponent of 2 by 2 to get b to the first. And the last come from the square root of 81, which is 9. Anything you could write for j other than prime, if you tried to FOIL it out, it won't equal the original problem. K and L, I can tell they're cubes. I can tell they're cubes because I see the x cube and there's 2 terms. For cubes, I write down what makes a cube, I write my template, and then I one of each, and then I pair them up. X cubed is a cube because it's x times x times x. 125 is a cube because it's 5 times 5 times 5. My template, first parentheses gets the same sign as the problem, second parentheses gets the opposite sign of the problem, and then plus. So same sign of the plus is a plus, the opposite of plus is minus, and then a plus is always plus. First parentheses, one of each, in this case 1x and 1, 5. Second parentheses, I start pairing. First pair is x times x. Second pair is x times 5. Third pair is 5 times 5. Multiply those out, and I have my answer. First parentheses is just going to stay x plus 5. Second parentheses is always prime, so I don't have to worry about trying to factor it. The x times x is going to give me an x squared. The x times 5 I'm going to write as 5x. And the 5 times 5 I'm going to write as 25. So x plus 5 and then x squared minus 5x plus 25 will be perfect. I'll do essentially exactly the same thing for part L. 27y cubed is 3y times 3y times 3y, and 64 is 4 times 4 times 4. First parentheses, same sign as the original problem, the same sign of minus is minus. Second parentheses, opposite sign from the problem, the opposite of minus is plus, and then always ends up with a plus. First parentheses, one of each, which means 1 3y and 1 4. Second parentheses, first pair is 3y times 3y. Second pair is 3y times 4. Last pair is 4 times 4. First parentheses stays 3y minus 4, ready to call something an answer. second parentheses, 3y times 3y is 9y squared, 3y times 4 is plus 12y, and 4 times 4 is 16. That second parentheses, ooh, it looks so much like it's going to factor, but it doesn't. It's prime. If you tried to factor it, it would be a disaster because it would be bottoms up. You'd go 9 times 16 and get 144, and you try to turn a 144 into a 12. It would be a nightmare to even try, but it's prime. M and N are both bottoms up. There's no common factors. Look at M has M's in it and N has N's in it. I don't think I was being that clever. And the signs for part M, because the original problem is a plus and minus, my signs are going to be a plus and minus. I'm going to bottoms up. There's no common factor, and because there's a number in front of the M squared term, I know I need to bottoms up. I'm going to start off multiplying by 5, and I'm going to get M squared plus M minus 30, and then I'm going to go into factor mode. I'm going to do an M plus and an M minus, and I'll start hunting around with the 30. The 1 in minus 30, that's not close to the 1 that I'm trying to get, so I'll move on. The 2 in the minus 15, I don't see a 1 there, I'll move on. The 3 in the minus 10, I don't see a 1 there. The 5 in the minus 6 is the pair that's interesting. It's either going to be 5 and minus 6 or negative 5 and positive 6. 5 minus 6 gives me a negative 1, and negative 5 plus 6 gives me a positive 1. Because I want a positive 1, I'm going to do a negative 5 and a plus 6, so I get a plus 6 and a minus 5. A lot of students in a class of 25, probably about 8 students, will just stop here and forget to finish up the bottoms up. But I need to finish bottoms up. Now I need to divide by 5, because I started off multiplying by 5. And then I need to reduce and bottoms up, and I'll do them both on the same step here. First fraction doesn't reduce, so I'm going to bottoms up it and get 5m plus 6. Second fraction reduces, and I'll get an m minus 1. N is also a bottoms up because there's no common factor, and the 3 in front of the n squared forces me into a bottoms up. There's no minus sign, so it's a double plus. So the first thing I'm going to do in my factoring is multiply by 3, and I'll get n squared plus 7n plus 6. Double plus factoring, so next step in bottoms up is factoring. I'm going to get an n plus and an n plus. And for the 6, my choices are 1 and 6, or 2 and 3. The 1 and 6 give me the 7, so I get a plus 1 and a plus 6. Now I'm going to divide by 3, and then I'm going to reduce and bottoms up. The first fraction I bottoms up and get 3n plus 1. Second fraction I reduce and get n plus 2. So my answer to n would be 3n plus 1 times n plus 2. And I'm confident that's correct. O has a common factor that I need to deal with first, and it starts off with a negative. Anytime you're asked to factor, if the first term is negative, you need to factor out the negative at least. Each of the numbers is divisible by 3, so I'm going to factor out a 3. They each have an x, I'm going to factor out an x. So I'm going to start off by factoring out a negative 3x. And then first, I'm going to figure out what goes first by taking the negative 3x cubed, dividing it by the negative 3x that I factored out. The negative 3's cancel to be a 1. X cubed over x is going to give me an x squared. And then for the next piece, negative 21x squared over negative 3x. Negative 21 over negative 3 is positive 7. I had 2 x's, I took 1 away, I'm left with 1x. And then the last one, 54x that I started with divided by negative 3x. Positive divided by negative is a negative, and 54 over 3 is 18, and I took that x away. It looked like I was going to need bottoms up, but I don't need bottoms up because the common factor stole the thing that forced bottoms up on me. So now I'm going to ignore the original problem, I'm going to ignore the common factor, and I'm going to 2 parentheses factor what's in that parentheses. First are a couple of x's, I have that template memorized. It's a plus and a minus. Now I'll work on the 18. I could do positive 1 and negative 18. Silly to even do negative 1 and positive 18 because that's not good. 2 and negative 9 or negative 2 and 9. One of those is going to work. 2 minus 9 gives me negative 7, and negative 2 plus 9 gives me positive 7. I want the positive 7, so I need that pair, which means the 2 goes with the minus, the 9 goes with the plus. I can't forget that common factor. It needs to be part of my answer. So my answer for part O is going to be that. Good. P, it's a double plus, so I know I'm going to double plus. It's also bottoms up because of the 2 in front of the b squared. There's no common factor, so I'm going to bottoms up. Anytime you're factoring with 3 terms, and if there's a number in front of the first term, you bottoms up. So I'm going to start off by multiplying by 2, and I'll get b squared plus 3b plus 10. And then I'm going to factor this. There's no minuses, so it's a double plus. Now I start writing the double plus factors of 10, which are 1 and 10 and 2 and 5. 1 plus 10 is 11. 2 plus 5 is 7. There aren't any double plus factors of 10 that give me 3. There's a plus and minus factor of 10 that gives me 3, but I'm not allowed to use minuses in this problem because I can't find the lasts for the factoring stage. This whole thing becomes prime, and all this was in some sense a waste of time, but I probably couldn't have figured out that this thing didn't factor unless I did the work. But something only factors when you can find the signs with the required signs that multiply to the last and give you that middle term. The next 2 problems are grouping because there's 4 terms. For Q, I'm going to go x squared plus 5x plus 2x plus 10. First parentheses, common factor of an x. When I factor out an x, I'm left with an x plus 5. Bring down the plus sign. Second parentheses, common factor of a 2. When I factor out a 2, I'm left with another x plus 5. Now there's a common factor of an x plus 5. When I take it away from the first piece, I'm left with an x. When I take it away from the second, I'm left with a plus 2. That's going to be my answer to Q. Now R, worst grouping because of that negative. I'm going to go 5x squared plus 10x in a parentheses, and when there's a negative, I stick that negative in the parentheses. First parentheses, common factor of 5x. When I factor out a 5x, I'm left with an x plus 2. Second parentheses, there's a common factor of 3, but I have to factor out that negative, so I'm going to make it a negative 3. And I can cheat because the parentheses have to be the same in a grouping problem for it to work, and that's what it would come out to be. Now there's 2x plus 2s. I'll factor out an x plus 2, and I'm left with a 5x and a minus 3 for my answer. That's all the factoring problems that are solely factoring problems. The next group of problems are the problems with the equal signs. And when problems have equal signs, you need numerical answers. Problems 2a and 2b are factored and set equal to 0. They're the best kind of problems. They're the least kind of work. For the first 2 problems, if something's both factored and set equal to 0, you shouldn't multiply it out. You should just take the factors and set it equal to 0. For 2a, any factor with an x gives a solution. The first one you divide by 2 and you get 0 over 2, which is 0. The second one you add 3 and get x equal to 3. So my answers for 2a, I'm pretty sure, are x equals 0 and x equals 3. It's optional, but I certainly can check. And it's not terribly hard to check, especially because I have a calculator. To check x equal to 0, I'd go to the original problem and go 2 times 0 times 0 minus 3 and make sure that equals to 0. To check the x equal to 3, I'd go to the original problem and go 2 times 3 times 3 minus 3 and make sure that equals to 0. I can do them both pretty quickly, I think, so I will. So first one, 2 parentheses 0 times 0 minus 3. If I hit enter and get 0, the answer is right. If I hit enter and get anything other than 0, I have a mistake. So it's right because I got 0. Move on to the next one, and watch me cheat. I'm going to go backwards, get next to the 0, hit my delete key, change it to a 3, go backwards, get next to the other 0, hit my delete key, change it to a 3. So I've, without actually typing that, I've been able to do that just by using the back arrow strategy of deleting, changing, deleting, or moving and changing, and it worked too. 2b is also a nice kind of problem because it's set equal to 0 and factored, and anytime a problem is both set equal to 0 and factored, you shouldn't multiply it out. You should just take each of the factors and set them equal to 0. For part B, the factor that has x plus 2, you would just minus 2, and that would lead you to a solution of minus 2. The 3x minus 10 is going to take 2 steps. You're going to plus 10, which will take you to 3x equal to 10, and then divide by 3, and that's going to give me x equal to 10/3. So for my answer, I'm going to say x equals negative 2 and positive 10/3. Part C, Part D need to be factored before I can figure out an answer. And the template for Part C is that. So in Part C, I'm going to factor it. There's not bottoms up because there's not a number in front of the x squared. So I'm going to x plus and x minus. And then for the 10, I can do 1 and minus 10, minus 1 and 10, 2 and minus 5, minus 2 and 5. I need the pair that gives me a negative 3, and this one does, because 2 minus 5 is negative 3. So I need a plus 2 and a minus 5. Because there's an equal sign, I have to go the extra mile and set the insides of the parentheses equal to 0. For the x plus 2 equal to 0, you'd minus 2 from both sides and get x equal to minus 2. For the x minus 5 equal to 0, you'd add 5 to both sides and get x equal to 5. So for my answer to part C of number 2, it's x equals negative 2 and x equals 5. I can check them. It's not terribly hard to check. I'll check really fast, actually. If I wanted to check x equal negative 2, I'd go negative 2 squared minus 3 times negative 2 minus 10. You put that on my calculator to make sure I get a 0. So I just go parentheses negative 2 squared minus 3 parentheses negative 2 minus 10. And that gives me the first 0 equal to 0. And for the checking the 5, I'd go 5 squared minus 3 times 5 minus 10. That would have to be 0. And again, I'm just going to hit the back, get next to the 2, go delete, delete. Now type a 5. Go back again, get next to the 2, go delete, delete, type the 5. So I didn't have to physically type the whole line again. I could just type over, and that gives me a 0 equal to 0 as well. So both the answers checked, and I'm even 100% sure that this is the correct answer. Part D, it's not factored, but it's set equal to 0. I need to factor it. This is bottoms up factoring. So the first thing I'm going to do is multiply by 5 and get x squared plus 16x plus 15. Then I'm going to factor, and I really like it when there's not minuses because then I just get double pluses. And then for my factors of 15, it's either 1 and 15 or 3 and 5. I need the pair that give me the 16, so it's a 1 and 15. And now I need to divide by 5, reduce, and bottoms up. For the first one, I'm going to bottoms up and get 5x plus 1. The second one I'm going to reduce and get x plus 3. And then at some point I need to introduce that equal to 0. I can't keep it out of the problem forever. It's just that in bottoms up, these lines don't really equal the original problem, so maybe it's not right to write it's equal to 0 at that point, but if you wrote it, it hardly makes a difference to me. Now that I have it factored and set equal to 0, I'll set the insides of the parentheses equal to 0. I'll go 5x plus 1 equal to 0, x plus 3 equal to 0. For the 5x plus 1, I minus 1 and get 5x equals minus 1. And then I divide by 5, and get x equals minus 1/5. And for the x plus 3, I minus 3, get x equal to minus 3. So the answer to D is x equals minus 1/5, x equals minus 3. I could check it. It's not terribly hard to check. It's a little harder to check a negative fraction than not. But I'll check the negative 1/5 without writing down the check. This is how you check it. You'd go 5 parentheses negative fraction 1/5 parentheses squared plus 16 parentheses negative fraction 1/5 parentheses plus 3. And that has to be 0 because when I plug an answer in for the x's, the left side has to simplify to be the right side, and it does. You could do the same thing for the checking the negative 3, but I'll skip that just to save a little time. E and F, they look a lot alike. And what they really have in common that's important is they're factored but they're not set equal to 0. And if something's factored but it's not set equal to 0, you need to destroy the factoring and get it set equal to 0 and refactor it. So if it's factored but not equal to 0, and that's not what the first couple problems were in this grouping, you need to clear the factoring or destroy the factoring, I guess. Set it equal to 0, refactor, and then get your answers. And that's the next two problems fit that bill perfectly. They're factored but not equal to 0. So I'm going to destroy the factoring by going x times x and x times minus 1. That's going to give me x squared minus 1x equals to positive 20. Now I'm going to minus 20 and minus 20 and get x squared minus 1x minus 20 equal to 0. And my template for this, a minus minus, is a plus minus. So I'm going to go x plus and x minus. And then the factors of 20 with the plus and the minus, like 1 and minus 20, minus 1 and 20, 2 and minus 10, minus 2 and 10, 4 and minus 5, negative 4 and 5. I need that pair. 4 minus 5 is negative 1. So I'm going to go plus 4 minus 5 equals 0. Now I'm going to go x plus 4 equal to 0, x minus 5 equal to 0. The first one's going to give me x equal negative 4. The second one's going to give me x equal to 5. I should check them because it's not that hard to check. So to check the x equal to negative 4, I'll go to the original problem, and I'll go negative 4 times negative 4 minus 1, and that has to equal 20. And then I'll do the same for the 5. I'll go 5 times 5 minus 1, and that has to equal 20. If they don't wind up equal 20, then I've messed up somewhere. So first checking, parentheses, which I don't really need the parentheses there, but it's okay to have them. So negative 4 times negative 4 minus 1, that better equal 20, which it did. And then the second one, I'm going to back, delete, delete, make that a 5, back, delete, delete, make that a 5. 5 times 5 minus 1, that also equals 20, so that answer is also correct. Any version of that, the same numbers with the wrong signs would be wrong. Like if I thought positive 4 was an answer, positive 4 is not an answer. If I put positive 4 in for the x's, I wouldn't get 20, so I can tell my answer is not right. The only numbers that work are -4 and +5. +4 doesn't work, -5 doesn't work, 20 doesn't work, 19 doesn't work. The only numbers that work are -4 and 5. I'm going to do the same thing for f. I'm going to get rid of the parentheses by multiplying. I'm going to go x times x and x times 1, which will give me x squared plus 1x equals to 20. I destroyed my factoring, setting it equal to 0 by minusing 20 and minusing 20, which gives me x squared plus 1x minus 20 equals to 0. And when my factors are plus and minus, my parentheses are plus and minus. So I get an x plus and an x minus. And for the 20, the 1 in minus 20 is hopeless. The 2 in minus 10 is no good. It's either a 4 in minus 5 or a minus 4 in positive 5. I think a minus 4 in positive 5 is what I need to do to get a positive 1, because the 4 minus 5 is a negative 1, but the negative 4 plus 5 is a positive 1. So I need a plus 5 and a minus 4. Now I set each of the parentheses equal to 0, so I go x plus 5 equal to 0, x minus 4 equal to 0. For the plus 5, you minus 5 and minus 5, and get x equal minus 5. For the minus 4, you plus 4 and plus 4, and get x equal to 4. So my answers to problem F of number 2 are x equals -5 and x equals 4. G is set equal to 0 but not factored, so I'm going to factor it. And it's an easy difference of squares. I divide the exponent by 2, I square root the number, get two essentially identical parentheses, one with a plus sign, one with a minus sign. Apparently I can't say essentially, sorry about that. Then I set the parentheses equal to 0. And I get a equal to -7 and a equal to 7. And you could write a equal to plus or minus 7, but for now that's completely fine for an answer. For h, it's not set equal to 0, so I'm going to set it equal to 0. I don't have any factoring to destroy, but all these number 2's have to be equal to 0. And so I'm going to go 25b squared minus 16 equals to 0. And it's going to factor just like the last problem. It's a difference of squares. I'm going to square root the numbers, divide the exponents by 2. So I'm going to do the square root of 25 is 5. B to the second power over 2 is b to the first power. The square root of 16 is 4. And get two essentially identical parentheses, one with a plus sign, one with a minus sign. The 5 and the b come from the first, the 14 comes from the last. And then I go 5b plus 4 equal to 0, 5b minus 4 equal to 0, and then I minus 4 minus 4, and get 5b equal to 4. Divide by 5, divide by 5, I get b equals to 4/5. And then for the other one, I plus 4 gives me 5b equals to 4. And then divide by 5, divide by 5, I get b equal to 4/5. And forgot a minus sign right here. I did minus 4 and didn't put the minus sign down. So my answer should be -4/5 and positive 4/5. Or you can just write plus or minus 4/5. I've got a bottoms up factor set equal to 0. I'm going to bottoms up. I'm going to multiply by 2 and get x squared plus 3x plus 2. Double plus factor. My factors of 2 that I can choose from are only 1 and 2. Fortunately, those add to 3. To finish up my bottoms up, I started off multiplying by 2. I'm going to divide by 2. I'm going to bottoms up. I'm going to reduce. So I did a fast version of bottoms up, but hopefully I've done enough bottoms up where me not writing, I'm multiplying by 2, now I'm factoring, now I'm dividing, reducing, and bottoms up. Hopefully this is enough at this point. Now I'm going to set the insides of the parentheses equal to 0. And then for the first one, you minus 1 and divide by 2. And you get x equal to minus 1/2. The second one, you minus 1, you get x equal to minus 1. So you get x is minus 1 and minus 1/2 for part I of number 2. I think that was an I. This is a j. I always put a problem, or I frequently put a problem like j on the test, and so often students multiply it out and don't even know what to do. So if you get the luxury of making a note card, you should put this exact problem on your note card and make a star to look for it, because it's probably going to be on the test. This problem is kind of like A and B of number 2, because it's factored and set equal to 0. You should make this a super quick problem. Anytime something's factored and set equal to 0, you just take the factors and set them equal to 0. You don't multiply it out. You're destroying something that's helpful. And this problem is so easy, it's hard, I guess. The first factor tells me x equals to 0. The second factor tells me x equals to 2. And that's the answer to part J. It's that simple. It looks simple, but students just do bizarre, they multiply it out. And anytime you have something equal to 0, you don't want to get rid of the factoring, you want to keep the factoring. If this was a number like 20, like in the problems with the 20s, then you'd multiply that out. But when it's 0, you don't multiply it out. My stack of paper is getting short. Got to be getting close to the word problems. So I've got K and L, and then a few word problems. 3 is a word problem, 4 is a word problem, and 3 word problems. So for part K, it's set equal to 0. It's not factored. It's not bottoms up factoring because there's not a number in front of the y squared. And it's double pluses because there's no minus signs in the problem. My choices for the 9 are 1 and 9, or 3 and 3. And 3 and 3 are going to be the ones that work. So I'm going to go y plus 3 equal to 0, y plus 3 equal to 0, minus 3, minus 3, get y equal to minus 3, minus 3, minus 3, get y equal to minus 3. You don't need to write the minus 3 twice, but if you wrote minus 3 comma minus 3 because it came up twice, that's fine. In college algebra, we say minus 3, the solution has a multiplicity of 2, meaning it comes from 2 different factors, but you don't need to write it twice, but it's not wrong to write it twice. L's not equal to 0. I've got to get it equal to 0 before I do my factoring. Did I skip one? Almost felt like I had more to do than that. J, K, I didn't. So I'm going to get this set equal to 0 because the factoring only makes sense when you have a 0 on one of the sides. So I'm going to make this b squared plus 6b minus 7 equals to 0. No bottoms up in this factoring. And for the 7, I can go 1 and minus 7 or minus 1 and 7. The pair I'm going to need are the minus 1 and 7. That's going to give me the positive 6. So I get a positive 7 and a minus 1. And now I go b plus 7 equals to 0, b minus 1 equal to 0. For the b plus 7, you minus a couple of 7s. For the b minus 1, you get a couple of 1s. And usually I go from here to the answer. I don't show this middle step. You absolutely don't need to show that middle step. If you could do that step in your head, it's completely fine. Now the 3 word problems. Hopefully the word problem section didn't kill you, and hopefully you can get them again. So first of all, we have to remember consecutive numbers versus consecutive even numbers, consecutive odd numbers. If the test says like this, consecutive numbers, then the numbers are x and x plus 1. But if it says either consecutive even or consecutive odd, they're both the same, I'd have an x and an x plus 2. In this case, we're just consecutive numbers. And so my first number is going to be x. The second number is going to be x plus 1. And the product means multiply. I'm multiplying the two consecutive numbers. The is means equals, and the 30 means 30. So for the product of two consecutive numbers, the first number times the second number is, which is equals, 30. And the math is just going to give me the smaller number. I'll have to add 1 to get the next number. I'm going to clear the parentheses. X times x is x squared. X times 1 is plus 1x. Now I'm going to minus 30 minus 30. And I get x squared plus 1x minus 30 equals to 0. I know my template for my factoring of this is plus and minus. And for the 30, 1 and minus 30 is not close to a 1. 2 and minus 15 is not close. 3 and minus 10 is not close. 5 and minus 6 is close, but it's the minus 5 and positive 6, because 5 minus 6 is a negative 1, negative 5 plus 6 is a positive 1. So I need a plus 6 and a minus 5. And now I'll go x plus 6 equal to 0, and get x equal to negative 6, x minus 5 equal to 0, x equal to 5. Remember when we wrote our answers, each one of these gets a pair, and the x equals 5, the number that goes with it, the consecutive number, is 6, because 5 plus 1 is 6. 5 and 6 are consecutive numbers, and they multiply to 30. For the x equal negative 6, you go negative 6 plus 1, and you get negative 5. So my answers come in pairs for this problem. The first pair are the numbers 5 and 6. Those are consecutive numbers. They're right next to each other on a number line, and they multiply to be 30. And the other pair is negative 6 and negative 5. They go together. They're next to each other on a number line, and they multiply out to be 30. So the algebra gives me 2 answers, but I kind of need 4 numbers, because I need the numbers that are consecutive next to each other on a number line that multiply to 30. If I wrote 5 and negative 6 for my answers, 5 and negative 6 multiply to be negative 30, not positive 30, and they're not next to each other on a number line, so they're not consecutive. I need to remember the area formula for a triangle. No, I don't. I need to know an area formula for a rectangle. And for a rectangle, area is length times width. And usually when I draw my rectangles to do these problems, I make the widths W's, and I make the width the shorter side, and I make my lengths L, and I'll make my lengths my longer side. The first sentence is going to help me get rid of one of the letters, and it says it's basically the garden is 3 feet narrower than it is long. That means the widths are length minus 3. So that's what the first sentence allows me to do. It allows me to get my W's in terms of the length. And now my area, the length times the width of this garden is 70 feet. That's what the second sentence says. But in place of the width, I can put L minus 3. So I'm going to go length times length minus 3 equals 70. Clear the parentheses. L times L is L squared. L times minus 3 is minus 3L. Set it equal to 0 by going minus 70 minus 70. This gives me L squared minus 3L minus 70 equals to 0. I need to factor it. It's going to factor to an L plus and an L minus. In the 70s, I could do 1 and minus 70, not close. 2 and minus 35, that's not giving me a 3. 3 doesn't work. I don't think 4 works. 5 and minus 14, I believe. That doesn't work. 6 doesn't work. 7 and minus 10, well, that actually works, because 7 minus 10 is negative 3, and 7 and then negative 10 are factors of negative 70. So I'll do plus 7 minus 10. Then I'm going to go L plus 7 equal to 0. L minus 10 equal to 0. I get L equal to minus 7, or L equal to 10. And in the geometry problems, we threw out the negative numbers because you can't have negative lengths or negative widths. So the answer to this is the length is 10 feet. And I know the width is the length minus 3, so it's going to be 7 feet. All right, one more problem, a triangle problem, a right triangle problem. And remember in my right triangle problems that we have a short leg, a long leg, and a hypotenuse. So generically, what the drawings that I did for right triangle problems, it looks something like this. I called this A, we called the short leg. B, we called the longer leg. C, we call the hypotenuse. And we know that this triangle obeys the formula a squared plus b squared equals c squared. I need that, even before getting into the problem, I have to have all that knowledge on my note card or in my head. And now I'm going to start filling everything in. The first sentence tells me the length of the hypotenuse, which is the c, is 5. So this side is 5 inches. Next sentence, it says the shortest leg, which is this, is 1 inch shorter than the longest leg. So this A is 1 inch shorter than the B, so the A is B minus 1. So first sentence gave me the C is 5. Second sentence gives me the short leg A is 1 less than B, which is B minus 1. Now I'm going to use the formula for A squared. I'm going to put B minus 1 squared, because A is B minus 1. I'm going to leave B squared as B squared, and for C squared, I'm going to put 5 squared. Now I'm going to solve this. B minus 1 squared is the tricky part. I have to FOIL that. I need to make it B minus 1 times B minus 1. I do firsts, which are B times B, which are B squared. Outers are B times minus 1, which is minus 1B. Inners are minus 1 times B, which is minus 1B. Lasts are minus 1 times minus 1, which is plus 1. So that's the FOILing of B minus 1 squared. I still have the plus B squared, and I still have the equal to 5 squared. On the left side, if I simplify it, I have 1B squared and 1B squared, which are 2B squared. Minus 1B and minus 1B looks like minus 16, but those are actually minus 1B and minus 1B, give me a minus 2B. This plus 1 stays, and on the right side we get 25 when you square the 5. Now I'm going to minus 25, and get 2b squared minus 2b minus 24 equals to 0. I'm going to put some work up here. I'm going to pull out a common factor of a 2 and get 2 times b squared minus b minus 12 equals 0. The 2, no factor that doesn't, if a factor is missing a letter, it's not going to give a solution. I could drop the 2, or I can keep it, but it's not going to help me to get an answer to this. Signs are plus and minus. I think the last are just 3 minus 4, because 3 times minus 4 is negative 12, and 3 minus 4 is negative 1. So I get it factored. I go 2 equal to 0. There's no solution because that doesn't have a letter. B plus 3 equal to 0 gives me b equal to negative 3. I throw out that solution because lengths of triangles have to be positive. Then I do b minus 4 equal to 0. I get b equal to 4. That must be part of my answer. And I only want the length of each of the legs. I can give you the hypotenuse, but you don't have to. So one of the answers is b equal to 4. And then for the A is 1 less than B, so it's 4 minus 1, which is 3. And if you want to, you can give the C, and I guess these are all inches. It would be nice if I took the time to write the units in. I don't get terribly picky. Probably if you forget the units, I'll write them on your test, but I probably wouldn't take points off if you forgot the inches. But if you're like in a science, like a chemistry class, they get crazy about your units, so you're going to make sure to get in that habit now so that if you take a science class, you don't get hammered for points that you don't need to miss. So that's the whole review. If you're feeling comfortable with the review, then you should rock the test. If you're not feeling comfortable with the review, then come visit me, send me an email, or do something so that I can help you before you get to the test. You want to feel comfortable before you take the test, because Because if you don't feel comfortable, then the test just isn't going to go well, and you need for the test to go well. And I try never to make them too hard, and I've got a ton of time to help you out, so if you need the help, just let me know, and I'll sit down with you as long as you need. All right, I hope this was good enough.